All right, what's happening there, my mathletes? That's right, Mr. Muscarella coming at you. And in this final video of theorems from our polynomial unit, we just did fundamental theorem of algebra, and now we've got one more, thanks to René Descartes, called the rational root or zero theorem. So go ahead and grab your paper, your notebooks, and let's go ahead and go through this last component of our polynomial theorems here. So we have the rational root theorem. Now, all this does is it tells us the number of possible rational roots or zeros. Doesn't tell us what they are, it just tells us possibilities. And there's a little formula. And I want you to memorize this little formula. You got to mind your P's and Q's as you go through this component of it. The P stands for the factors of the constant. And the Q are going to be the factors of the leading coefficient. So we're going to put that into practice here as we go through two examples together, and then we'll give you two to practice on your own. Then we'll come back in one other video to tie everything together into sketching one function based on the given information. So for now, let's take a look at example number 7. So what I like to do is I like to highlight everything, so I mind my P's and Q's. So whatever technique you want to use, go ahead and do that, but my P, remember that's the factors of the constant, and my constant in this case is 6. And then the Q are going to be, that is the factors of my leading coefficient, and going to be the value of 2. So what I do is I just generate a little list. Now in order to get 6, so let's kind of think about this for a minute. To get 6, I could have 1 times 6, or I could have -1 and -6. So notice how we have a positive and a negative for each one of those pairs of integers. So when we write that, we'll do plus or minus 1, and then we're going to leave some space and then do plus or minus 6. Now I could also use 2 and 3 to get 6, or -2 and -3 to come up with a product of 6. So that's why we'll put a plus or minus in front of each one of our terms there and commas in between it. So to get 6, we have those 4 different combinations of factors. Now we'll do the same idea with our leading coefficient, which is 2. In order to get 2, you only have positive or -1 times positive or -2. So those are my options there for that. Now to generate the list of possible zeros, we're going to take everything in the top row, and notice the first term in the Q row is 1. So we're going to divide everything by 1, which is just going to give us the same value. So I'm going to have 1 divided by 1, which is just 1. And then plus or minus 2, plus or minus 3, plus or minus 6. So all of that comes from taking everything in this top row and dividing it by 1. So that's going to give us our first group there, our first list. Now, our second group is going to come from taking all of the terms in P in that row. We're going to divide everything here by 2. So the first 4 came from dividing everything by 1. The second group is going to come from dividing everything by 2. So we just take our time when we do that, right? And we're going to say, okay, what's 1 divided by 2? All right, so 1 divided by 2 is going to be 1/2. So plus or minus 1/2. So we write one other one. Now we go to do 2 divided by 2. That one, if I take 2 divided by 2, so 2 divided by 2, well, that gives me 1, and I've already got that. So I don't have to rewrite that term again, or that possible zero or root again, because I already got it. So that's cool. So we don't have to do anything with that. Awesome sauce. Then we're going to go to our next term, 3 divided by 2. All right, so we've got to write that one. So plus or minus 3 divided by 2. And then lastly, we've got our 6 divided by 2. So 6 divided by 2, oh, that gives us 3. So 6 divided by 2, again, that's already one of the ones that's listed, so we do not have to list that one again. So what's really cool about that is we only have to list the possible 0 one and only one time. So that list of numbers that we have generated right there are the list of possible roots or zeros using René Descartes' rational zero theorem. So that first 4, they come from dividing everything by 1, and that's going to be a pattern. You see, usually whatever's in the numerator is going to automatically be there to start with. And then the ones on the second term from Q, some of them will be repeated, so we don't have to worry about that. So that's our list there that we get from that guy, from our very first one. Now let's go ahead and try number 8 together. Now in number 8, if you think you got it, just pause it, get after it on yourself, then come back and see how you did. But when we take a look at this one, again, our Q value and our P value. So first our P value, now that is -8. And then our Q value, so our constant there in front of the leading coefficient is 2. Now, a couple things to think about here. To get -8, so I'm just going to generate a list. I could have 1 and -8, or I could have -1 and +8. So again, notice how we have a positive or a negative of each one of those terms. Same thing if I do 2, I can multiply that by -4, or I could do -2 times +4. So I have positives and negatives for each one of those values. So again, we're going to list plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So that's going to be my list for my constant. Now my leading coefficient, again, is 2. So we're going to have plus or minus 1 and plus or minus 2. And again, just take your time as you generate that list. So the first component of it, remember, everything's divided by 1. So that is going to just be all the same terms that are in that P row. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 3, or not 3, that was from the last one. See, I'm thinking too fast here. 4, and then plus or minus 8. So all of those are from the very first factor of 2. Now the next group, so again, we take our time here. And we're going to do 1 divided by 2. All right, cool. So that's going to give us 1/2. So we're going to have plus or minus 1/2. And then when we do the next term, 2 divided by 2, that gives us 1. And check it out, we've already got that one listed, so no reason to repeat that. And then we have 4 divided by 2. All right, so 4 divided by 2. Again, that term is already listed because 4 divided by 2 is 2. So we don't have to write that. And then lastly, we've got 2 dividing into 8, and 8 divided by 2 gives us 4, which also is already listed. So that one was not nearly as cumbersome as last one. So these are my possible roots or zeros for the polynomial that we're given there, number 8. Now we've got 2 more for you to try on your own. So let's get after it, right? So there's 9, there's 10. So go ahead and hit pause. Try these 2 on your own, and then come back, and let's see how you did. All right, so how did we do with numbers 9 and 10? Hopefully, you came up with all of the factors, possible zeros there that we see. Now, if this were a quiz, these would be the pieces that we'd be looking for. You definitely want to show your work for organizing your table to come up with your list of possible factors for your P and your Q. Make sure you include the plus or minus with all of those. And then be sure that you get the correct list of factors, and one of them is going to come from the first factors, and sometimes we might give you that other point for the second group of factors. So when you show your work, make sure you include all 3 things. All right, that's it for this video. Thank you guys for watching. Come on back, watch the next one where we put everything together in this polynomial here that we've got. So this is where we're going to put all of it together. So I look forward to seeing you guys then. Make it a great day as always. I'll catch up with you later. Peace out.